Yes, this is, okay, so yeah, this is second set of notes. So we had exponential rules and then now. Okay, so rational expressions. So this rational expression is, you're going to see a lot of it. You may have seen this a little bit in Algebra 1, probably not. I think sometimes depending on snow days, they get to this or not. But this is huge in pre-cal and on the calculus and stuff. So rational expressions, the definition is the ratio of two polynomials. So you can think of that about it as really just a big fraction. I know how you all love fractions. So it's a fraction with an equation on the top and on the bottom. Okay. So everything we did last chapter and the chapter before were polynomials, right? Like quadratic, cubic, linear, etc. And those are the ones we could factor and solve. Well, now a rational expression is a ratio of two or a fraction made up of two polynomials. Okay? So we're not going to deal with this kind of notation very much, but I do want to explain this one little piece of it because you'll see that on ACT problems and stuff. So this is P of x over Q of x, where Q of x cannot equal 0 is how this notation is wrapped. And I want to explain what this Q of x cannot equal 0 means. When we're talking about fractions, what's the value of this? What does that equal? 0, right? What does this equal? Nope. Undefined, right? So on any kind, and I'm going to do this a lot in this lesson where, because we're dealing with equations that are fractions, I'm going to talk about numbers that are fractions because a lot of the same rules apply. So just like you can't have a 0 on the bottom of a fraction, when you're talking about equations that are fractions, an equation on the bottom can't equal 0, okay? So when you're looking at something like this on the ACT, it may have a rational expression where maybe the bottom is x minus 3. So then over to the side, it would say x cannot equal 3. So all that means is for this equation, x can't equal 3 because if it did, the bottom would equal 0. Okay, so whenever you see this kind of notation, it's just saying whatever values make the bottom 0, x cannot equal those values. Okay, and that gets into the domain of these functions, and we're not going to really study that this year, but next year in pre-cal you'll talk about it a lot. Okay, but that's just what that means. So what we're basically going to do today is in this little text right here, where it says the rational expression is in its simplest form when its numerator and denominator are polynomials and have no common divisors. So that actually could be, you could substitute the word fraction in for rational expression if you wanted to, because what this is saying is, let's take 8 over 6. Is that in its simplest form? No. How could we get it to simplest form? Alex, what would we do to get it to simplest form?
Divided by
2, right? Because basically 4 times 2 is 8, 3 times 2 is 6. They have a common divisor, right? So you could cancel those out and get 4 times 3. So just getting it to where they have no common divisors means you're getting it in simplest form. Okay, so that's how you simplify fractions. It's also how we simplify rational expressions. Okay? But to find rational expressions, to find what divides into rational expressions, we have to factor. So we're going to use all kinds of factoring. So tell me one of your favorite kinds of factoring, if you have a favorite. Just somebody name a type of factoring. Magic question. So we're going to use magic question. What else? AC method? GCF? And I think I have an extra blanket here, really, so there should really be one more. What else? It's my favorite kind. What else? Square root, well, it's called difference of squares, right? So everything else that we've learned, like quadratic formula, like solving by square roots, even like some of the difference of cubes, those all involve solving equations, all right? And we're really not dealing with those. We're dealing with only factoring. So only the kind where you could break it down into like a distribution problem or like a FOIL problem, okay? So to simplify rational expressions, we factor if possible, and we use all the kind of methods we listed. And then we cancel matching factors from top and bottom. So just like on this fraction, where I canceled the matching 2's from top and bottom, we're going to cancel factors. And then here's the most important part of this whole lesson. If you end up zoning out here on this lesson today and you just can't listen anymore, at least remember this. When we factor and cancel out stuff, you cannot cancel out factor families. So that means when we break up polynomials into factors and we put them in parentheses, we want to think of those parentheses as a factor family. Like if we factor something that got an x plus 3. Once you put it, once it's associated with like plus and minuses, that's a little family that you can't break up unless you could cancel it out with another x plus 3. Okay, so that, and I'll talk about that all throughout our examples, but this is the main point you want to remember, is that as you factor, you can only cancel whole families, not pieces. Okay, so no one wants to break up a family, right? Okay, so so this first example is actually doesn't involve factoring. This is more like one from your homework, right? Because it doesn't have any pluses or minuses. It's just a lot of different factors multiplied together. So who can tell me one where we could start trying to simplify that? What can we do? Just like homework. 27 divided by 3 gives us what? 9, right? So we can take out a 3. 3 goes into 27 9 times, so we get a 9 on top, right? What else? The x squared and the x to the third gives us what? Right, x to the first on the bottom. So that cancels and leaves 1 there. And what about the y's? 1y on top, right? So that actually is more like our homework than it is actually the rational expression, but still, same rules apply. We're trying to get all the common divisors canceled out, right? Now, this next one is going to involve factoring. Because when we've got this equation up top, which with the minus sign, or with the plus or minus, that means we first have to factor it before we can cancel things out. So how can we factor that top line? What can we do? Take out a 2x, and what do we have left? We have 4x squared. If we take out a 2x, we get a 2x left minus a 3, right? So we GCF. We factored by GCF on that one, and two pieces to that, right? The greatest number you can take out and the most amount of x's. So we took that out. So now we want to see if we have common factors. So we've got a 2x here and a 2x here. So those can cancel. This one in the middle, within the parentheses, couldn't cancel, right? Because it's part of a family. The outside 2x's can cancel. And we're left with 2x minus 3. Okay?
So the GCF
right, because neither of these were part of those parentheses, right? Were part of a factor. So because neither of them were part of the factor, they could cancel each other out. Okay? All right? Let's look at another example. Now, one way that would really help to help you not to cancel out families, or not to break up families, is anytime you have an equation like this, like x minus 3, that does have plus or minuses, if it's in its slowest form, go ahead and put parentheses around it, okay? And that way you can always remember you can't cancel out pieces of parentheses, okay, or parts. But what about the bottom? X squared minus 9. Meredith, what do you got?
X minus 3.
Right, x minus 3x plus 3. So break it up into factors. So now we're only looking at the factored part, not the x squared minus 9. So now we can cancel factors if they're the complete factor. So now we have an x minus 3 here and an x minus 3 here. So now these can cancel. I'm left with nothing on top, so I have to put a 1. And I'm left with x plus 3 on the bottom. That stays on the bottom, and that's our final answer. So just because we had nothing on the bottom doesn't mean the x plus 3 gets to go up there, right? It still has to stay on the bottom of the fraction. Okay? All right, let's look at the next one. So 2x squared plus x minus 10. Again, one thing I want to caution you against, ever, so don't even write this down when I do it, but you don't ever want to look at this and think, oh, minus 10, or x squared, all right? You cannot do that. You'll see a lot of these on the ACT. When it is an equation, you've got to simplify it and factor it, okay? So, how could we factor that? What kind of method do we have to use? Emily? Let's see, so you're going to walk me through it with the help of your classmates. So what's the first thing we have to do for AC? Well, we try, but can we? No. So what's the first step? Sarah, help her out. So AC, what do we do first?
3 times 10.
Gives us negative. So we ask what multiplies negative 20 adds to what? 1. And what does? Sarah? No, that's going to add to like 19. Well, multiplies negative 20 adds to 5 and negative 4. So I'm going to put negative 4 there and 5 there. Okay. And what do we do next? Count.
2x squared minus 4 plus 5x minus 10.
Yeah, very good. And then what? Split down the middle. And we can take out, over here we can take out what? A 2x. We're left with x minus 2. Bring down our plus, and between 5x and negative 10, we can take out a 5, right? So we're left with x minus 2. So what's our final factors for that? Julie, what's our final factors on that? Right, x minus 2 and 2x plus 5. So now we're not looking at this equation anymore. We're looking at the factors, x minus 2, 2x plus 5. So what about the bottom? Can we factor that? Julie?
Magic question.
Uh-huh. So what is the magic question we're asking? What multiplies to
3. Multiplies 10 x 3.
negative 10 is 3. Anybody help her out? What? 5 and negative 2. So x plus 5, x minus 2. So now we're looking at the factors, not the equation. So what can cancel? What can cancel? Right, the x minus 2 can cancel with the x minus 2 because again they're factors, but we can cancel out the complete factor. What about these plus 5s? Can they cancel? No, right. So now we've canceled everything we think. So we pull out what we've got left. We've got a 2x plus 5 and an x plus 5. And again, even though they look oh so similar, they're part of families. We don't break up families, so we're done. Okay? Very good? All right. Now it's going to get a little tricky. Let's look at this next one. So, Sarah, how can we factor the top?
With a magic question.
Okay?
I broke it up into x minus 3 and x minus 2.
Right, x minus 3, x minus 2. Okay? Now, how can we factor the bottom? Keep in mind it's 4 minus x squared. Abby, what do you think? It's 2 terms. This is subtraction. both squares. Well, it would be x minus 2, x plus 2 if it were written like this, okay? But you have to keep in mind here the 4 is negative, here the x is negative, x squared is negative. So really to factor this, you have to keep it in the order it is, and it's actually 2 minus x, 2 plus x, okay? Because these two terms would multiply back to get this, right? These two terms, or these two factors, would give you this, right? X plus 4, x squared minus 4. And the thing you have to remember here is 4 minus x squared is not the same as x squared minus 4, right? Because the signs are opposite. Yes.
Are you ever going to come up with like a sample for this game?
Not with the trick I'm going to, what do you mean about trying to,
Like if it was x squared.
I mean, you'll get difference of squares, but, well, anytime, I guess I'm not sure. I mean, you could get them in weird orders and have to move them around to cancel, if that's what you're asking. But this is really probably the main example we're really looking at in this class. Does that make sense? Okay, so we factored this way, but again, to cancel factors, they have to be the same. And x minus 2 is very, very close to 2 minus x, that they're not the same, right? In fact, they're complete opposites, right? Because here, the x is positive, here the x is negative, here the 2 is negative, here the 2 is positive, right? But man, they're close, and we really want to get this as simple as we can. So can anyone come up with a way that we could make those the same? Okay, I'll still be. So if we want to change the sign of everything, what number do we use normally when you want to change the sign of everything in a phrase? -1, right? So what we can do here to get these to cancel is we can take this and we can think about taking out a -1, like taking out a -1 as a GCF. So if we took out a -1, the negative x becomes positive, the positive 2 becomes negative, okay? And now we can cancel those out. Okay, so now they cancel, but we still have this -1 in our equation, and it has to stay. All right, so it's kind of goofy, but it is a trick that you have to apply, because as you all use these later on in pre-cal and calculus and stuff, the whole point of these, of simplifying these equations, is to get them as simple as possible. So you want to apply, like, this trick to get this a lot simpler than what it started out with, okay? So now, nothing else can cancel, right? X minus 3 can't cancel with 2 plus x. So we're done, kind of. So we gather what we have left. We have x minus 3 left up top. On the bottom, we have a -1 and a 2 plus x. Okay? So that's one way to write the final answer. But the way you'll see it a lot, like in the books and stuff, and on the ACT, is anytime you have a fraction, and either the top or the bottom is negative, it really just means it's a negative fraction, right? If they were both negative, they'd cancel out and be positive. So the really right way to write this is just to bring that negative out front, because it really just makes it a negative fraction. Okay? Questions about that?
Yep, you can look at this.
You don't have to. I think it's, well, in this case, I would, because this shows how we have not really distributed that negative. You know, if we wrote it without the parentheses, then we might think it's, yeah, you're just safer just keeping the parentheses, especially with the negative out there. Okay.
Do you only do the -1 when you have two, like two, a third different?
Right, complete, well, and that's a good point. You really only need this trick, I'll call it, is when you have when you have subtraction that are complete opposites, right? Because if it were addition, if this were an x plus 2, then I really could just cancel them, right? Because x plus 2 is the same as 2 plus x. I mean, because they're both positive, they're just written differently. Whereas x minus 2 and 2 minus x, each of those have completely different signs. Does that make sense? So if it's plus, I could have just rewritten it and been done with it, okay? Because I'm not changing any signs, I'm just changing the order, okay? Alright, so we'll use the strict again, in a little while. Okay, let's try this next one. So, looking at this, we want to factor, Caitlin, start there. How do we factor the top?
Take out
A 5 and an X, right? So GCF, again, two parts to GCF. The biggest number you can take out, which is 5, the most amount of X's, which is 1, and we're left with X minus 3. Amelia, what about the bottom? What can we do at the bottom?
3x.
How many X's can we take out? 2, right? So the biggest number is 3, most amount of X's is 2, and we're left with X minus 3. So, Catherine, so what can we cancel out? X minus 3. And can we cancel out anything else? Maybe, what do you think impossible? The X's. So, if you think about the parentheses as families, think about the extra stuff as singles. And singles can cancel out. We don't care about singles. So, and we do care about singles. But, so the parentheses have to be the exact same to cancel out. But the singles, so anything like GCFs or something that are just getting multiplied in that's not part of a plus or minus, those we can cancel out or simplify just like on your homework, right? So even if we stopped here and thought, oh, I think we're done, you can come over here and write your answer, and then look at your answer and think, oh no, I could simplify that further, okay? So don't forget everything we learned in homework. Looking at this, you would never want an answer that has 1 X on top, 2 X's on the bottom, right? So we can simplify that X with 1 there, and that's our final answer. Okay, so there's lots of different layers to this. And a lot of times you'll want to do what we just did here. Like cancel out what you can, go ahead and write an answer, and then check it again and make sure it's your final answer. Okay? Take a call when you go, I'll get you my questions about this. Okay. All right, now, so that's just simplifying. Okay, that's just simplifying rational expressions. What we're going to do today is also multiply and divide. So first of all, I want to talk about okay. If I want to multiply that fraction, how do I do it? There's a couple different ways. So who can tell me how they would multiply that fraction? What's that?
No, it's pretty close.
Right, yeah, you can't cross multiply unless it was an equal sign, right? But you can multiply straight across. So if we did that, we would get 2 times 10 is 20, 5 times 8 is 40, and then what would we do? Simplify to what? 1/2. What? How can we do that? Divided by 20, right? So 20, so if you can take out a 20, you get a 1, take out a 20 here, you get a 2, so you get 1/2, right? That what you're saying? Okay. All right, now what's another way? So this is completely right, but what's another way we could do it from here? Sarah?
You could like take out one of the 5s and then you can put it out twice in the 10,
Right.
one of the 2s.
Right. So 2 goes into 2 once, 2 goes into 8 4 times. 5 goes into 5 once, 5 goes into 10 twice. And then, so then if we multiply across, we'd get 2 over 4. And then we can do it again, right? Like 2 and 4. Okay. You guys go back there? So either one of these ways is right. The first one was just multiplying straight across and then reducing. Next one was simplifying anything on the top with anything on the bottom, right? And then multiplying straight across. So we're going to do the same thing, only now we've got big old equations with them. So when you're multiplying rational expressions, it's the same as multiplying fractions. We're going to factor if possible, which is the same thing as like simplify if possible. Cancel factors, top and bottom. So anything on the top can be canceled with anything on the bottom, but they have to be on, top and bottom. They can be diagonal, or on top of each other, but they came down the same level. And then we're gonna, whatever we have left, we're gonna multiply straight across. Okay? Now, you don't really have the same options as with fractions, because looking at this first equation, you really would not want to multiply this by that and then try to simplify, right? So you always want to simplify first, cancel, then multiply across. Okay? Alright, so let's try this. See, so one problem here involves factoring with 3 different equations, right? Yeah, this one, it's right on the wall. What's that?
Since we have to simplify everything and then
Yep, you get really good. I told you all you would use factoring in your everyday life, right? And we've used it like every day. So we learned how to factor. In math, right? Well, what else life is there? Like math is it. Okay. Anyway, I don't even believe that, but Callie will start to bring it up. I don't use it except in class, anyway. You never know. It's very necessary, though, in the world. Okay, so Callie, how can we factor that first? So what would it factor to? No. Nicole, you want to help her out? Oh, Nicole, how do we factor that?
Do you add them and then?
Well, no, so we're just trying to factor this. So what multiplies negative 12 adds to 1. And actually, Kelly came up with it. 4 negative. Girls are quiet. Yeah, positive 4, negative 3. All right, I'm going to start calling on even more people because everybody's talking. And actually, Alyssa, you're not talking, but I haven't called on you yet. So pick something else to factor. So we got to factor this, and we got to factor this. Which one would you like to factor? Okay, what would it factor to? Well, it's 2 terms. It's a subtraction. Right, x minus 3, x plus 3. Okay, that's okay. You don't have to know the names. You just know how to do it. Sophie, 2x plus 6. How would we factor that? QCF. So what could we take out? And what do we have left? X plus 3. Can we do anything with x minus 5? We're going to go and put that in with that. All right. Let's see, Kristen, so what can we cancel out? Anything on the top with anything on the bottom. What's that? Anything on the top. So any of these 3, do they match any of these 3? Go fast.
X minus 3.
X minus 3, X minus 3. What else? X plus 3, X plus 3. Anything else? What about this X and this X? No, right. Okay. All right, see how much fun this is? Okay, so now we collect everything we have left. So we have an x plus 4 and a 2. So 2x plus 4. And we have an x minus 5 on the bottom. And now we're done. That's our final answer. You could, if you can distribute if you want to, but I wouldn't take off if you did. But you're really better off not, because when you look at your final answer, you want to make sure nothing else can cancel. And by leaving it factored like this, it's really obvious that nothing else can cancel. Okay? So we're done. Okay, it's not that bad. Yeah, there you go. Okay, now I did do you all a favor in these notes in the fact that we only had to do AC method once. This is the same equation, all right? So this factors to 2x plus 5, x minus 2. It's the same one we did last. Let's see. Who else? Sarah, so what about, so pick one of these and factor.
I work it out. I really do it out.
Well, so what's the major question on this one?
When multiplies into 14 equals -9.
And it's -9, so what do you think? 7 or 2. And they would be what? Both negative, right? Emily, what about 4x squared minus 25?
Difference of squares.
Difference of squares.
So
2x minus 5 and 2x plus 5.
Right. See how factoring now is just becoming so easy because we've done it so much? Yeah. Okay, so Katie, so now we get the fun part. So what can we cancel?
Your 2x plus 5 and then your x plus 5.
5.
And then your x minus 2.
That's 2. What about this 5 and this 5? No, right. Very good. Okay, so now we've canceled everything we can. Let's see what we have left. The only thing we have left up top is a 5. On the bottom, we have x minus 7 and 2x minus 5. And we're done. Okay. Rational expression. Actually, to give you a little preview, in pre-cal, like we're not graphing these, but these are the ones where the graphs look like, you've probably seen some. The graphs kind of look like that, like they're all in pieces and stuff. So you'll learn. I'll leave that for next year. All that excitement. But these are used a lot, but just not more. Okay. All right, so let's try the next one. So the next one is kind of an exercise in a bunch of singles. So the next one doesn't really have any equations in it, right? Like they're all just a bunch of factors multiplied together. So there's no plus or minus in, right? No addition or subtraction, I should say. So we don't really need to use these.
So are they families?
These are not families, no. Families are only held together by pluses and minuses. So on this one, we can kind of think about them as all a bunch of singles, all right? So we can kind of cancel. They're having fun. They're out of their bar. No, I'm teasing. But so we can kind of cancel out anything on the top with anything on the bottom. So let's try something. So Kristen, pick something to cancel, or to simplify, I should say. A. Okay, so we had how would we simplify the A's? Right, so this one cancels out, right, with one of these, so we have 1A, right? Sophia, what else? The B's, how do they simplify? Right, so this B, we can subtract, right, 5 minus 1 gives us 4, or you can think about it as in one of these cancels with one of those, and we end up with 4 B's. Julie? Right, the Y's both cancel, because 1 minus 1 is 0, right, or you can think one or the other. Okay, we're loving this. Z's, how do they simplify?
C.
Oh, C. So we have just what? They go away, okay? Nicole, what do you think? Where? On the bottom, right? Okay, so this one cancels. We get Z2 on the bottom. Everybody's leaving the numbers till the end. Alyssa, what do you think about the numbers? And actually, no one's right. I'm just calling on people. Everyone gets to join in on the fun. Okay, so think about when we were multiplying just fractions. Anything on the bottom can simplify anything on the top. So what about like 2 and 12? Could that simplify? Yes, so, okay, so 2 goes into 2 once, goes into 12 how many times? Hey, Julie, help her out what about the other ones? What about 27 and 9?
3.
Where?
Top.
The top? I put a 3 here?
Yeah.
Okay. And what I put down here? What does this turn into? A 1. Okay. All right, so let's stop there.
Do you have to put the 1 there?
No, you don't have to, but it's nice to show something. But no, you don't have to. So now let's see what we got left here. So up here, go to the bottom. We have A, B to the 4th, and a 3. So 3A, B to the 4th. On the bottom, we have an x squared, a z squared, and a 6. Okay. So, that looks pretty good, but what else can we do now? Caitlin, what can we do? What happens to them?
So, there's a little topic.
Right, so you don't have to write that one, but we can. The final answer. Okay? Yeah, I know, but we're not gonna do too many of these. Okay? Okay. All right, so let's try it again. What's that? Yeah, no, I don't need it on record.
I like to know that we talked or something. What are some, they're gonna be like, oh,
Okay, Liz, pick an equation and factor.
X plus 4 and then X minus 4.
She knows about Liz, don't you?
No, I call it Liz. I mean, sometimes you know.
I have it written down on my seating chart.
That's okay.
First day.
My
you
name's
said, no, I have it written down that you go about Liz sometimes, but maybe you said that the first day. Okay, so pick one to factor.
X plus 4 and then X minus 4.
Okay, so this one right here, right? Okay.
I didn't register because not that many people call me that. So I didn't register.
I can show you what I have it written down next to your name, but, oh, Lily, I haven't called on you at all. Pick one to factor. Okay.
GCF,
So what's the big,
parentheses, X minus 4.
X minus 4? Who else am I? Cameron, pick one to factor. Amelia, you're next, so. Top one?
X plus 5, X minus 1.
X plus 5, X plus, not 4.
1 and 4.
Okay, X plus 4, X plus 1, right? Okay. Amelia, what about the, you're left with the last one. What do you get? Multiply to 16, add to 8. Meredith, help her out. 4 plus, there you go. X plus 4.
You're probably scrolling down this further.
I know.
No, yeah.
But I also wanted to start becoming automatic. So Julie, you get to cancel. Girls are quiet. What's the cancel?
X plus 4,
X plus 4, X plus 4.
X minus 4.
X minus 4, X minus. And this brings up a good point. You can only cancel 1 to 1, top and bottom. Okay, so we only have 1 x to the 4th x plus 4. We can only cancel 1 x plus 4 here. Even though we have 2 down the bottom, they do not cancel each other out because they have to be different levels. So really, this is it. That's all we can do for that one. Okay?
You make it X plus 4 squared.
Yes, we can write it like that. We want to be very fancy. So we have 2x plus 1, and we can write it x plus 4 squared. Or if you wanted to, I would not take off if you wrote it like this. Okay?
I got it. What's up?
I think here I have that written down. Yeah, Kat, I may not have had that written down. But Liz, I did. Okay. Questions about those? All right. What's that?
You gotta whisper that and hurts to laugh.
Oh my gosh. No more funny business here. The whole thing. It's gonna be very serious. Okay. There's one of the laugh. All right. Oh my gosh, if you need to walk out, you can, because I know it's gotta hurt. Okay. So now we're doing division. All right. So, come on, let's get serious so Kate doesn't hurt herself. Okay. All right, now, let's go back. Stay quiet. Let's go back and do some division. Okay. I know, so we're going to get back to this. Elizabeth, how would we divide those fractions? How do you divide fractions? Abby, you want to help her? No, that's next place. Sarah. What's that? Right, so some of you may have learned it as keep, change, flip, right? So you keep the first one, you keep the first fraction the same, change from division to multiplication, flip the second. It's stupid? Talk like Aristotle. Okay. Alright, so really division, after this first step, just turns into multiplication, right? So how would we simplify this now?
What?
Emily, what would we do?
Oh, sorry, I was looking at the last one.
Okay, yeah, I'm looking at it, scared. What do you do now?
30 over 20.
Right, so again, you could multiply it all out and simplify, but what we want to get in the practice of is simplifying, right? So 5 goes into 15, 2 goes into 4, and we get 3 halves.
Do we have to do it like that?
Well, I mean, we're going to be doing these equations, so yeah, you have to. If you're doing just fractions, no, you could have done it the other way, okay? But I want you to start thinking about always trying to simplify first, okay? What's that? Well, so this becomes, so this is the final answer, right? So 30 over 20 would also be 3 over 2. Okay, again though, you guys know how to do all this, I hope, so, alright. Okay, what's that? Because I want to show you how dividing rational expressions is the same process as dividing fractions, right? With just a lot more stuff to do. So when you're dividing, you're going to flip the second fraction, change it to multiplication, and then just finish with the multiplication problem. Okay? Now, here's my warning about this. I know a lot of you, it hurts your hand to write too much, or it's a long problem, or you might run out of paper. So you're going to try the shortcut, all right? And just be really, really careful in your shortcutting, because it is, even though you know that like you should flip it, but if you don't visually flip it, it's really hard to cancel these out. I mean, I've been teaching this for like 8 years, and you just need to somehow flip it, okay? I'm going to go ahead and do it the long way, but there's shortcuts to do it, but always, at least when you factor it, write it out flipped, okay? It's just really hard to keep track of it if you don't, okay? So I don't want to cramp your hand or anything, but you really do need to try to write it and flip it. So, first thing I'm going to do is I am going to rewrite the problem, at least on this one. So I'm changing it to multiplication. So before I've done anything, before I've factored anything or canceled anything out, I'm going to rewrite it. Go to quiet, please. We're recording. Okay. So I've changed it to multiplication and I've flipped it. Now I will give you all this one again is AC method. It's still the same problem. So it's still 2x plus 5 over x minus 2. Now, Katie, I haven't called on you too much. Pick one to factor.
Okay, the top one on the right
Okay.
is it 5x? Oh, you take out a GCF.
Yeah.
And then it's plus 5.
Right. So that was, so I'm sorry, I kind of led you on that one. So yeah, that one's a GCF. Take out take out a 5, you're left with x plus 5. Catherine, Callahan, you want to pick one?
The one on the left on the bottom.
Okay.
And it will be, well, you do magic question, and then it will be x plus 5.
Minus 2? Yeah. X plus, is that right? Yeah, x plus 5, x minus 2. And Lily, making up for lost time. What did we do with the last one?
GCF.
Uh-huh. What were we at GCF?
3x.
And what are we left with?
2x.
2x. Okay. Ainsley, you want to cancel? What's that? You can cancel all you want. What's that? X plus 5, x plus 5. X minus 2, x minus 2. Very good. So x plus 5, x plus 5. All right, anybody see anything else? All right, so now let's see what we got left. So if on top we have a 5, on the bottom we have a 3x. Yeah, that's kind of amazing, right? So we took this huge, complicated problem, and our answer is 5 over 3x. Isn't that fun, Paige? Is that laughing? Isn't that fun? Okay. All right. All right, let's try just 2 more.
Oh, yes.
Okay. All right. So again, first I'm going to rewrite. Okay. So first, let's just rewrite. So change it to multiplication. Flip it. Okay. So same situation we saw earlier. Caitlin, or actually, yeah, Caitlin. How do we factor 4 minus x squared?
Oh, it's 2 minus x, 2 plus x.
Right, 2 minus x, 2 plus x. And Elizabeth, what about this one?
X, x. Oh, x minus 2.
Right, x and x minus 2.
Wait.
That's it? Okay, very good. Now, so,
Once you put the x in flip it to
oh, actually, I should have. Yeah, there should be, not a mistake, 2 plus x. Okay, so we really want these parentheses to cancel, so what do? How can we make this match this? Take out a -1, right? So we want to rewrite it like this. Okay, and now what can we cancel? Answers. I don't want to put on there. Julie, what can we cancel? I hate the canceling last time. Callie, what do we cancel?
x minus 2.
X minus 2. So that kind of takes care of the parentheses, but we got some singles hanging around. Cameron, what can we do?
The x is not to the 3
And make this a what? 2. Bless you. Anybody, Abby, you see anything else? Oh, is it too far away, for you?
No.
Good.
I'm confused.
Okay, so actually, yeah, it is kind of a mess now. Kind of a mess, a lot of numbers. So let's gather everything and then judge, right? So we got 2x squared.
Why is that?
Because we canceled out these x to the third. But it's kind of got messy, so it's bothered Abby, so we're going to regather.
Did you take out that x to the beginning from your?
Yeah. But hang on, still not under here. So we got 2x squared, we got a -1, and we got a 2 plus x. So I'm not right, I'm just gathering everything we've got left. And down here, we have an x and a 6. Right? So again, I'm just showing you all one way to approach it. When this gets really messy, or if you can't stand to look at all that stretching out, then regroup, come over here, okay? And now, Abby, what can we cross out? So this, right, can cross out with one of those, right? 6 becomes a, now anything else? No. Okay, so now we can rewrite it for real. So we got a -1 times x is really just negative x, 2 plus x over 3. Okay, so again, don't get, just do what you can and then see what it looks like and then see what else you can do. And yeah, these problems are not ones necessarily that you can do all in one, like 2 seconds. They take a while. Okay? Questions about that? Okay, now, last one. one is called, this one has a special name. It's called a complex fraction, right? Now, it's actually pretty easy. So who should I pick on? I'll do Julie in the back corner. Okay, so I want you to pretend that I can't see this problem. Okay? I know. So pretend I can't see this problem and read to me what it says.
2x plus 14 divided by 9
Okay.
divided by x.
Divided by
X squared minus 14.
minus 49.
Oh, yes.
Okay. All right. Actually, you didn't do exactly. So one way most people have answered this question has said 2x plus 14 over 9 divided by x squared minus 14 divided by 18. Okay, which is fine either way. But a lot of times, just saying it out loud like that actually tells you this is the problem, right? So it's not as hard as it looks looking at it like this. If you write it out like this, it's just like what we've been doing. Okay? So when all you guys can do this one on your own. All right, so simplify it. So we simplify it like this. What am I missing? I'm missing something. What else can I simplify there? What can I do up here? X plus 7. So now, what can I cancel? X plus 7, X plus 7. Alyssa, what else?
A 1, or you change the 9 to a 1 and the 18 to
2. Anything else?
Didn't the 2 multiply?
Yes. So now we multiply everything we have left. So 2 times 2 is 4 over X minus 7. Yay. All right. Okay. So, let me turn that. All right. So that is simplifying rational expression.